Look at quadratic functions. This is number 10, I believe, in 3.1. And on number 10, same idea. They've got a little bit of distractors in here. They're mentioning that you have a shot put that you release at 55 degrees. That doesn't matter to us. That doesn't really come into play. What matters to us, once again, is this idea that we have a quadratic function, and quadratic functions have the format where they have ax squared plus bx plus c. And we know what those values a, b, and c can kind of do for us to help us understand. So they gave us a visualization of this graph already, so we don't even have to go through and talk about, like whether or not it's a maximum or a minimum. We can clearly see that this guy has a maximum right here. So that means the first part we're going to go take a look at is that vertex. And so remember, to find the vertex, we say that the x portion of the vertex, right, because the vertex would be an x comma y. To find that vertex, we would use the negative b over 2a. So in our particular problem here, we find out that our a is equal to negative 0.02, and our b value is 1.4. So those are the coefficients in front of your x squared and the coefficient in front of your x. So we plug that in, so we get x is equal to negative 1.4 divided by 2 times negative 0.02. Pull out my trusty calculator, and I find out that I have negative 1.4 divided by 2, open parentheses. That's not going to work. I didn't do that right. So let's go that way. Negative 1.4 over 2 times negative 0.02. And that comes out to be x equals 35. And that kind of makes sense, because if you see this, there's 20, there's 30, so it's like 35. Yep, so x equals 35. So we know that this is the part. So we have 35 is going to be that number right there, but we need to find out what that maximum height is. We need to see like what this value is over here on the y-axis. So remember, to do that, we plug it back into our function. So we're going to take our function and evaluate it at 35. So we get negative 0.02 times 35 squared plus 1.4 times 35 plus 5.4. All right, I'd recommend that you plug this into your calculator a little bit at a time, unless you're really confident with your calculator. So I'm going to do 35 squared, and then I'm going to take that number and multiply it by negative 0.02. So this value right here that I received was negative 24.5 plus 1.4 times 35. That gives me 49 plus 5.4. And then we can go just plug that all into the calculator at one time. And so I get negative 24.5 plus 49 plus 5.4. And I come out that my function is going to max out at about 29.9 feet. So that makes sense. If you zoom that in, you kind of see that. Like I come over here and I click on my and I come back over. It's loading, and you can kind of see like that kind of makes sense. It looks like it's at 30, but 29.9, that's basically 30. And we come straight down, that's about 35. So we look like we did pretty well. So close that out. And so what they're saying is it says, what's the maximum height? So we're going to say 29.9. Oh, wait. Type an integer or a decimal rounded to 4 decimal places. Okay, we're good. All right. And then our feet, we said, was 35. So that's our shot puts distance from the release. So 35 feet from the release, it will be at 29.9 feet in elevation. We check that. Nice work. All right, so we keep moving. So now it says, what is a shot put's horizontal distance to the nearest tenth of a foot, or the distance of the throw in feet? And so what that's saying is that at what point will, what's the furthest this thing is going to travel? All right, so I'm going to clear screen and kind of reboot on this. Okay, so what they're saying is like, if we pull this guy back up, so what we just calculated a minute ago was this, like how high is that going to go? Now they're saying, what I'm reading this as, it says, what is the shot put's horizontal distance that it's going to travel? So that's going to be this distance going right here. So like how far until it hits the ground, right? Because this is how high it is. So this is looks like this person must be about 6 feet tall, maybe, right? Because that's 5'6", and that's 10 feet right there. So they're about 6 feet tall. So imagine they got the shot put, they're running, they're pushing the shot put, right? And it's flying through the air at 35 feet from the distance from the person. It's at 29.9 feet high in the air, and then it starts falling. And someplace out here, like there's 70, so that's like almost 75. There's 80, so about 75 feet. But one thing we know about that location right there is we don't know the y value. But what we do know about this is that, remember, when we think about this, this is the x-axis. And in that case right there, on the x-axis is what we're looking for. So the x is the part that we're trying to find, is how far. But one thing we do know about that spot is that on the y-axis, which goes up and down, on the y-axis, I'm not up anymore. I'm on the ground. So if I'm on the ground, that location, the y value is 0. So one cool thing that we can do about that is we know at this point that since our y value is equal to 0, we can do some stuff with our equation. Let's go back. I'm going to clear screen and go back to our particular problem and take a look at this. So it says, what is the shot put's maximum horizontal distance? So in that particular case, what we've identified is that we know that the y value for this function is going to be 0. So we can say f of x, which is going to be equal to 0, is equal to negative 0.02 x squared plus 1.4x plus 5.4. And so now we have this ability to be able to solve that because we know what the y value is going to be. We want to find out what x's will make this function equal 0. So I'm going to use, because these are crazy numbers, I'm going to use the quadratic formula. And so just a couple quick reminders. Remember that this is going to be my a value, right? So it's a times x squared plus b times x plus c. And so my quadratic formula is x is equal to a positive, excuse me, I wrote that wrong. X is equal to a negative b plus or minus the square root of b squared minus 4ac all over 2a. And so what that means for us is that we're going to go in and actually like find or plug in those values that we know, plug in our coefficients that we know. So we know that our a value is negative 0.02. We know our b value is 1.4, and we know our c value is 5.4. So when we plug these in, then we'll be able to solve this. So we got negative 1.4 plus or minus the square root of 1.4 squared minus 4. And I like to use parentheses because it kind of helps me keep things like separated, times a times c. And then all of that over 2a. Okay, now let's walk through and kind of like plug in these numbers and kind of sort through. So what I would highly recommend is that let's focus our energy on what's inside of the parenthesis or the radical. Okay, so let's go through and get that value first. I think that'll prove the most valuable to us. So I'm going to kind of talk you through like what I'm doing here. So I'm going to grab my calculator. I'm going to leave the negative 1.4 alone, positive or negative, and I'm going to put it all over. And, because that's easy on the bottom, I'm going to go ahead and multiply that out. So 2 times negative 0.02 is going to, 2 times negative 0.02 is going to be negative 0.04. So I just went ahead and took care of that. I got that out of the way. And then I'm going to do the radical. So I'm on my calculator, I'm going to do 1.4 squared. Okay, so that gives me 1.96. Then I'm going to go through, I'm going to put my minus sign. I'm going to take my numbers right here and multiply them together. So I'm going to do 4 times the negative 0.02 times the 5.4. So 4 times negative 0.02 times 5.4. Now, this is a situation where you don't really want to be using your cell phone, right? And the reason is because your cell phone is not going to show you. So using some type of either online calculator or using, like I have a TI 30 Pro, I'll turn my camera on real quickly. Let me see if I can do that still while this is closed up. I don't know if I can. No, I can't turn my camera on during the recording. So sorry about that. So, you know, like you want to use some type of calculator besides just like your phone. Like, you know, that was kind of why I recommended no phones for this class when you're doing stuff. All right, so that's what I get. So check to see if you can get those numbers. Now let's talk about this. So I had the minus sign. I brought the minus sign down right there. I took my positive times my negative times my positive, and I got a negative. But now when I plug this in, I'm going to keep on chopping away at this. So I got my negative 1.4 plus or minus the square root. And I'm going to go ahead and plug in that 1.96 minus a negative 0.432. So minus a negative 0.432, and that comes out to be 2.392. And because I'm a good housekeeper, I'm keeping everything nice and neat. Okay, now I'm going to go ahead and take care of that radical. I'm going to see what I get from that radical. So I'm going to take the square root. So square root of 2.392. I get some big, long, nasty decimal. So I get 1.4 plus or minus, and I get 1.5466609, blah, 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 blah. It keeps on going. All over negative 0.04. So I'm just going to plug in because you'll notice here it says type an integer or decimal round to the nearest tenth. So as long as I'm going out quite a few decimal places, it shouldn't impact me. So what I'm going to treat this as 1.547. I think we should be good. So basically this 6 right here, let's change colors. This 6 right here rounds that 6 up to a 7 because we have those rounding rules. So if you're 5 or greater, then the number in front of it goes up. So if I round that to this value right here, so that's what I would get. So I'm going to plug this in my calculator real quickly. I'm out of space here. That's unfortunate. So I'm going to do negative 1.4 plus, now this is tricky. So I got negative 1.4, and I'm going to hit pause real quickly. All right, so I moved some stuff around so that way we can kind of see like a calculator at the same time as my equation. So what I'm going to do is I'm going to type in my entire numerator right here. So I'm at the top. And you'll notice I have positive or negative. So I'm going to explain that as I'm going. So I'm going to do negative 1.4, and I'm going to do plus, and remember we're doing 1.547. All right, and so that gives me that guy right there. So I'm going to go ahead and write that real quick. So for my numerator, oops, I didn't see what I got there. So I get for my numerator, I got 0.147. So 0.147 divided by negative 0.04. And then so I'll just hit divided by. So that'll pull up the previous answer. Nope, that's messed me up. Let's go back on that. All right. And so we'll press enter. That gives me the answer. And then if I say divided by, nope, that didn't work. It didn't do the right thing. So no worries. So I'm going to take 0.147 and I'm going to divide it by my negative 0.04. And so I get my negative 3.6. So one of my answers, the plus version of this answer, is equal to, I have a terrible memory, sorry, negative 3.675. So negative 3.675. And that was the plus portion of this. So now I have to go do the minus portion. So I pull my calculator back up. So now I'm going to do negative 1.4 minus my 1.547. So I get that. Then I'm going to take that. And so I'm going to take my negative 2.947 and I'm going to divide that by my negative 0.04. And I find out that the negative portion, 73.675. So the negative portion is going to be negative 76.73, excuse me. Like I said, I have a terrible memory, especially when I'm trying to remember things and talk. So negative 73.675. So that's the minus part. So what do I mean by the minus part? Yep, got that right. So the minus part is because this equation is both going to look at a positive version and a negative version. So now let's try to make sense of this because I feel like something went awry. Because remember, we're supposed to be finding out how far out this went. And what we just found out is that both the times it went out is negative. So let's check my work real quickly and see here. So on this one, we did negative 1.4 minus that. That gives us a positive divided by negative gives us that. And this gives me minus that. All right, let's go back and recalculate this one because I think that's where my error is in play. All right, so let's pull up the calculator one more time. No, that was right. It's not negative, it's positive. My bad. There we go. So there's my mistake. This is positive 73.75. So when we pull the graph back up and we take a look at that, we can see that what we've calculated is that one of the locations that it would be equal to at 0 would be negative 3.75, which would be like right here. The other one would be is it would travel all the way out. There's 70. So 73.675 would be my other distance. All right. So that's our one way that we can use. So that actually means quadratics are actually kind of like special is that we can model situations, we can create these equations, and then from those equations, we can then go from there. So quick recall, we have this answer, negative or positive 73.675. So 73.675. They ask us to round it to the nearest tenth. So that means we're going to take, and that's the 6 right there. So the 7 makes the 6 go up. So this would be 73.7 feet. And so we'll close this. We'll come here and we'll say 73.7. We'll come down here and we'll check. And we got it. Is there anything else to this question? Oh, there is. So let's clear and reboot. All right. So from what height was a shot put released? So this is a very similar circumstance. So we pull the graph back up, and the last part to this is that look at that idea and kind of use the same concept that we did on the last one, and that is this idea that here we are and we're looking at this, and like this out here would be when we don't know the x, but we do know that y is equal to 0. Vice versa over here. If we want to know how tall the person is, then in this case right here, we know that the x value is 0, but the y value is what we're looking for because the y is how tall that spot is right there. So in application, that's how tall the person is. And so in this particular case here, we would do a very similar thing. This one's much easier because now what we're doing is we're trying to figure out f of x, which is, oh my God. We're trying to find out f of x, which in this case is going to be our output or our height. That's our y value. And that is going to be equal to, we're going to do this when the function when x is equal to 0. That will help us find that y and that height. So this makes it really easy because we say negative, we say negative 0.02 times 0 squared plus 1.4 times 0 plus 5.4. What happens is this just goes away because 0 times anything just turns into 0. 0 times anything turns into 0. And we walk away from this problem finding out that when x is equal to 0, the height or the function is equal to nothing more than 5.4 feet. So this particular person is about 5.4 feet tall. So let's close out some of this stuff here. And it says round and enter to the nearest tenth, so that we're already there. So we got 5.4. Come over here and check our answer. And we got it. Let's see what else they give us. That's it. So working with quadratics, we have these specific characteristics that we want to be able to plug in. The biggest thing that's just to wrap your head around is, when do we use the 0? When does that 0 come into play? And so just kind of refreshing that idea is that, remember that the whole big picture here is that this is my x-axis, this is my y-axis. if I am on the x-axis, no matter where I am on the x-axis, I know that I haven't gone up and I haven't gone down. So in an ordered pair where the x comes first and the y comes second, what I do know is I know that x is an unknown. Like right here, I have an idea x is positive, but I don't know exactly what it is. But what I do know is the y portion is 0. This point right here, same thing. I have an idea what the x is, but I know for sure that y is equal to 0. And this guy right here, same thing. I don't know exactly what the x is, but I know for sure that y is equal to 0. And the same thing